number 8, or number 18, excuse me, on page 456. This is a chapter 8 review, and we're going to use the traditional method here. So, step A is going to be to write the null hypothesis and the alternative hypothesis. To see whether people are keeping their car tires inflated to the correct level of 35 pounds per square inch, which is abbreviated PSI, the tire company manager selects a sample of 36 tires and checks the pressure. Right now, there's probably a lot of people with low tire pressure. Anybody know why this time of the year? Low tire pressure?
Change in temperature.
Change in temperature, right. A lot of people need to put more air pressure in their tires right now. And that affects how long your tires last, too. It affects the wear and tear on the tires. So, now it says the mean of the sample is 33.5 PSI. So that's your X bar, your mean of your sample. 33.5 pounds per square inch. And the standard deviation of the sample they're talking about is 3 PSI. So that's your S. Are the tires properly inflated? So they're trying to check if the correct level is 35 pounds per square inch. So we're talking about average tire pressure. Average means we're going to use, wait, hold on here a second. Yeah, okay, this is not a chi-squared one. Sorry, I thought I was doing a chi-squared. I'm going to go ahead and do it though, okay? Because this one also involves a confidence interval, which I think would be a good one to review. So we're talking about averages. We're talking about the mean. So we're trying to determine whether the mean is really at 35 pounds per square inch, or the mean is not equal to 35 pounds per square inch. The claim's not very clear here. On the test, I'll make it a lot clearer. But it says, are the tires properly inflated? To me, it sounds like they're questioning whether that's really, it seems to be that they're saying that they're not 35 pounds per square inch. So we're going to call that the claim. Although I don't think it's real clear. It could probably be done either way on this problem. Step B is to find the critical values. We're talking about a mean, so you're either going to use Z or T. Our sample size is greater than 30, so we're going to use Z. One-tailed or two-tailed?
Two.
Yep, see an equal sign, that means two-tailed. We have two tails here. We have two critical values. They're both going to be Z values. Our alpha value on this one is 10% or 0.10. So we need to divide that by 2, because there would be 5% in each tail. 5% here, 0.05, and 0.05 in the right tail. So that leaves 90% in the middle. If we divide that by 2, what's 90% divided by 2?
0.45.
0.45. So this is going to be 0.45. Of course, another way to find that would be to take 0.5 minus 0.05, and that would be 0.45. So you go to your Z chart, you look up 0.4500, look to the left, look up, and you know what you get for a Z score? 1.65. It's two tails, so you need two critical values, so the right one will be 1.65. The left one will be negative 1.65. And those two values are my critical values. Any questions about that? Okay, now we got to do the test value. Now, let me try to give you a little bit of the logic here. If our test value is more than 1.65 standard deviations, standard errors, from the mean, then we're going to reject this null. But if our test value, 33.5, is less than 1.65 standard errors from the mean, then we won't reject it. So 1.65 is kind of like that line in the sand. If we go over that line, then we're going to reject. Okay, kind of like I said, you cross that line and you punch it, you know, that type of thing. You cross that line, we're going to reject you in null hypothesis. If you don't cross the line, we won't reject you. All right, so test value. We're using Z. Here's the formula. It's X bar minus mu over the population standard deviation, but since we don't know that, we're going to use the sample standard deviation divided by the square root of n. So we're going to go 33.5. I'm going to need some help on the calculators. Minus 35 over S, which is 3, divided by the square root of 36.
-3.
-3. So that tells me that 33.5 is 3 standard deviations below 35. Statistically, that's a long ways. That means we're way out here. -3 standard deviations would be way out here. We're way out here in this tail area. So what are we going to say about the null? Reject. Statistically, 33.5 and 35 are not considered close. So we're going to have to reject the null. Now, if we reject the null, that means we think the null's false. That means we think the alternative is probably true. We're not proving it, but that's what we think. It's most likely true. So we're going to say there is enough evidence to what?
To support.
To support, good. There is enough evidence to support the claim that tires are not properly inflated. Of course, there's other ways to say that. You could say that the tires do not have an average of 35 psi. So that's the hypothesis test part of it. Now we're going to do the confidence interval. Any questions about these 5 steps? On the test, basically, it'll be 1 point per step on each problem that are like this. All right, let's go to the hypothesis test. Now, for the hypothesis test, our formula is, and this formula is on your Chapter 7 formula sheet, so you're going to need that for the test. It's x bar minus your z-score times your standard error of the mean, which is population standard deviation, over the square root of n. But we don't know the population standard deviation, so we'll have to use a sample standard deviation, which is S. Over here, it's going to be the same thing with an addition sign in the middle. And mu is going to be between there. So for x bar, we're going to put in our sample mean, which is 33.5. Our z-score was 1.65. Our standard deviation was 3 pounds per square inch. N is 36, so square root of 36. We're going to type it in once with a plus and once with a minus. And that's going to give us our 2 values here.
32.68.
So let's round that to 32.7. And how about when you use a plus?
34.33. Okay, 34.3.
Okay. So there, and the labels on these would be pounds per square inch. This is a 90% confidence interval. So what that means is we are 90% confident that the true average amount, the true tire pressure is somewhere between 32.7 and 34.3 pounds per square inch. We're 90% confident of that. Now, I want you to look up here at our null. Our null says it's 35. We're 90% sure it's between 32.7 and 34.3. So based on this, should I reject that it's 35 psi or not reject? Reject, yeah. 35 is not in here, is it? 35 is not in here, so that means 35 is not in here, then we don't think the mu could be 35. We should reject, which is exactly what we said right here. So we're going to say that our results agree, and they should always agree. If we do both methods right, they should always agree. Results agree because 35 is not in the interval. And we rejected the null. What if 35 was on this interval? Then what should we have said right here?
Except
Yeah. If this number falls in the interval, then we should have said do not reject here. But since 35 is not in the interval, it's correct that we said reject.